Welcome back to the workshop. As promised in the last video, we paused it primarily because we reached over 20 minutes and we don't like them going any longer than 30 minutes at the worst. So here we are back. We're going to continue talking about RSLogix5000, but this time we're going to create a project. So in the last video, we did a discovery of items in the menu that were grayed out because there was no project file. Now we're going to create a project and we're going to look some more. Let's do it. Welcome back. In the previous videos, we did kind of a cursory discovery of the environment for RSLogix5000. Now we're going to create a project. When we did the cursory discovery, there was nothing to open, nothing to view, nothing to edit. In order to have a file to work with, you have to first create the file. First thing, creating a project. So it said to open up RSLogix5000 from the start menu or from a shortcut on your desktop. That's what you have in front of you. We're going to go File, New, and we start selecting our configuration. I happen to have an L31 processor. That's a processor with two RS-232 ports on it, no Ethernet. It's the least expensive processor available that will work with these revision levels, 17, 18, 19, and 20. That's why we picked it. Don't be afraid to buy compact Logix used on eBay or on other sites that are reputable. I've only had but one that had a problem with it. I've purchased maybe 25 L31s used on eBay, and I've only had one that was flaky. You probably have an L31. If you don't, pick the processor that you have. If you have one of these newer ones, like the ER or ERM, and what that stands for, Ethernet redundant with motion. These are the new 5370 controllers. You remember in an earlier video I showed that in Studio5000 those are the only compact Logix processors you have to pick from, are 5370 controllers. Pick your controller. I'm going to stick to the L31 because that's what I have on my lab station right now, and I never pick an older rev level of software. 20 is the highest revision level that you can program an L31 with. So we pick 20, and for a name, we said beginner underscore L31. You can name it anything you want. I typically give them some sort of a name so when I'm looking back later through the files, I can find it. Notice here it says create in. By default, there is a folder that has been created already for you called projects under the RSLogix5000 directory. However, I don't typically use that folder. Instead, I create one. So I'll go to desktop. I'm going to create a folder, right click new, and I'm going to call it RS5K beginner recording. This just means it's a folder that I saved these projects in when I was doing these recordings. I'm going to go pick that folder. So I'm going to have to go to desktop, go down to PLC Professor, RS5000, RS Learn, right here. I put it in Learn RS5000. If you create this folder and you hide it from yourself, you're liable to be successful and not be able to find it. That gives us an empty folder to put beginner underscore L31 in. L31 processor, version 20, I gave it a name. I could give it a description, that's not necessary. Say OK. This is where all the geeks at Rockwell Software go to work in the background creating the structure for your project. So this is all done for you. There's types in here, meaning classes of objects. And by the way, if you don't familiar with the phrase class of objects or instances of classes of objects, you need to do a little research on the web and kind of build up a little knowledge of information object models, information object modeling, classes of objects, and instances of those classes. Because that terminology is going to be used from now on, anything RSLogix5000. So there we created a new project. We go through and explain some of the structure in here. Let's look at some of the structure that was created for you by RSLogix5000 development software. These are all folders that some you absolutely have to have and some you might need. For instance, the ones that don't show a expansion in front of it, like this one. See, there's no user-defined data types, there's no add-on defined data types, and there's no module-defined data types. But there are predefined and there are strings. Data types, the only thing you're going to find in this folder and its subfolders are classes of objects, but you won't find the instances of those class of objects. If you create an instance of any of these class of objects right here, that instance will either be in the controller tags database or a program tags database. That's where you'll find the instances that you created of these data types. We start at the top here. If we were to double click on controller tags, there's nothing there. You don't have any controller tags for two reasons. One, you haven't created any. If you had added IO modules, there would be some here of the module defined type. You see over here under data types, module defined. Right now there's nothing because you haven't added any module. We'll close that. We don't care about the controller fault handler or the power-up handler in the first couple volumes of this series for the beginner. That's a more advanced subject. Sufficient for you to know where the controller tags is, and I will just say this, that you could also call these global tags in the sense that they are available to any program in the controller. So they are controller-wide tags. Whereas these tags, program tags, this database, those tags are only available to that specific program in that specific task. If you know from reading the manual or watching other videos that the Logix engine, depending on the processor, can have up to 32 unique tasks. There's only one here, the continuous. You can create more. You could always go to task, right click, and create a new one. Now it automatically shows a periodic task. You see the little blue clock here, as opposed to this folder has a clockwise swirly? That's because the continuous task has a little clockwise circle or swirly, and you can only have one continuous task, whereas you can have multiple periodic tasks. Don't worry about that for right now. It's way ahead of us. And inside of that task, one of 32 tasks, we can have one of 100 different programs. We've only got one program here, that's all we want. Within that program, you're going to have a tag database that is program tags only for this program. If you had 4 programs created under main task, each one would have its own unique program tag database. All 4 of those programs could use the exact same tag names, but one program can't access the tags in another program. And then, of course, your main routine, that's where you start putting your logic. Besides the main routine, you can have more routines, subroutines. That's enough for that right now. Under task, programs, and routines. We won't deal with motion groups until we get to probably volume 4 of this series, or you could always jump ahead and buy volume 2 of the other RSLogix5000 series. We do have a series, 2 manuals, RS5000 volume 1 and volume 2. They are extensions of what you learned in RS500 when you did the Complete PLC Learn series manual with either a MicroLogix or a SLIC 500. Those 2 manuals start from where we left off with 500, but they introduce you to this graphical user interface, RSLogix5000, and then we go from there with more advanced subjects. You can always jump to one of those 2 manuals. We have no add-on instructions. And for data types, the only one that we have here right now that is of any interest to us at this point are predefined. So I'm going to expand that. Holy moly, look at that. Look at all of those predefined classes of data objects. These are all data types. I want to point out something in here. We'll start with Boolean. If I double click on that, nothing pops up. That's because it is what Rockwell calls an atomic data type, meaning that it is an atom that you can use to make up molecules of data. I'll show you that one. And let's move down here. We have a dent. That's a double integer. If I double click, nothing pops up. That is a 32-bit word. If I keep going down, I see integer. That's a 16-bit word. Long integer. And let's see what else we have. Real, which to you is floating point. But notice I'm double clicking on these and nothing's coming up. Single integer, that's 8 bits. Okay, now I want to pick on one that's not an atomic data type just to show you what I mean by atomic data type. So I'm going to pick timer. I'm going to double click. Ooh, now something pops up. Now see, when I double clicked on the atomic data types, nothing popped up because there is nothing to them. They're either an 8-bit single integer, 32-bit double integer, etc. But a timer data type is a molecule made up of atomic data types, and the molecules are 2 double integers and through Boolean. This double integer is the preset value, so this timer data structure has a preset value that the timer will be timing for that length of time. And then it has an accumulate register. That's where it stores how much of the time has been accumulated since you enabled it with the Boolean data type. This bit, timer timing, will be on as long as it is accumulating towards the preset. And then at some point the done bit will come on. Okay, so you see, this is not a timer. This is a timer data structure. It is a class of data objects. It's not an instance. But it is an instance of this data type will be the backing tag for a TON instruction or a TOF instruction or an RTO instruction. All three of those instructions use this data type to back them. Okay, so that's what's in predefined data types. And I'll just pick one here to alarm you, called the alarm. Holy smokes, look at all this stuff in there. We've got 96 bytes of data. Some of them are real, floating point, some are Boolean, some are double integer, and so on. That's quite a complex molecule of atomic data types of Boolean, real, and double integers. So we're going to cancel that. That's enough exploration for now in the predefined data types. Module defined, you're not going to see anything there until you add a module. The reason that there's nothing there, now all the predefined data types are here. I don't remember how many. There's not quite 100. I think there's 60 some predefined data structures for you already configured. The module defined data types, I suppose they could have included all of those right here and then put a plus sign next to it. But there are so many, it would create an unruly list. It's better to add them to your list as you add them to your project. And you'll see, if not in a few minutes in the next video, you'll see exactly what I'm talking about. And of course down here it shows you the I/O configuration. The I/O configuration shows you nothing at this point because there's no I/O modules added. If this had fixed I/O, like an L24 ERM or ER or an L23, L23E, it comes with fixed I/O. You could expand the bus and see the I/O points that came with this controller. But this controller, the L31, is just a controller. Does not have a power supply, does not have any I/O, and it does not have a right end cap. At this point, we want to add I/O modules. That's what we're going to do next. However, before we add some I/O, there is one thing that I want you to do. I had you do it in the manual, so we'll put it in here. And that is go to controller properties, go to channel 0 port. You got channel 0, and you've also got channel 1. Channel 1 is the upper RS-232 port, and channel 0 is the lower. As you look at your, if you have an L31, you have two RS-232 ports. I typically plug the cable into the lower one to leave the upper one for access to something else. We're going to use channel 0. Now, I had you notice that the baud rate is set at 19.2. The processor that I'm connected to, it's probably set at 38,400, which is the highest baud rate allowable for this driver. So I'm going to pick 38,400. 38.4 is slow, but 19.2 is twice as slow. Nowhere near Ethernet. Ethernet processors are more desirable, but they're also much more expensive. Personally, I would learn on the least expensive processor I could get my hands on, and then later on sell the L31 online. You'll get a couple $100 for it at least, and then go buy an L32, an L35, an L23E, L24E, L16ER, anything with Ethernet on it. But I wouldn't let that get in the way of you learning the $200, $300, $400 more you're going to pay for a processor with Ethernet. I had you set it at 38.4 and then apply it. Okay, the next thing we did was saving your project. You know from working with documents that there's almost always a floppy disk symbol up here that says save. Now, for those of you that are under 30 years old, computers don't come with floppy disk drives in them anymore. It always surprises me that they've kept that symbol for save. The symbol of a floppy disk goes way back. If I want to save, I can click on that. However, as a novice, you would probably go, okay, file. I probably want to go to file. I can save, and since this is the first time I've saved it, it's going to ask me to name it. If you've already named it once and you want to name it something different, or save it in a different location, then you would pick Save As. I'm going to pick Save As to cover both bases. Well, there it is, RSLearn5000, RS500, but I put it in a folder called RS5K Beginner Recording. Okay, I'm going to save it here. I've already named it. Even though I picked Save As, what I want you to see is if you just pick Save, then it puts it wherever it thinks you last told it to go. I like a more deterministic approach, so I normally would use Save As to make sure it goes to the folder where I want it so I can find it again. We saved our project. Now we're going to download our project. So we go to Communications. Now if you go here and pick Download, that's a bit of a crapshoot. That's like pinning the tail on the donkey. For those of you that aren't familiar with that game, it's a game kids play at a birthday party. They've got a picture of a donkey, not life-size, but pretty good-sized picture with no tail. And then they blindfold the kids one at a time and give them a little piece of paper that looks like a donkey's tail with a tack on it. And they have to walk around blindfolded, find the picture of the donkey, and pin the tail on the donkey. If you hit download here, you really don't know where it's going. I always tell my learners, go to Communications, go to Who Active, and it's going to show you who's out there. Now see, if you do it the other way and there's no processor out there connected, it's going to take a long time. It'll time out and say, I couldn't find it. Now the message doesn't say that, but it says couldn't find such and such processor at such and such path. This way, Who Active is deterministic, so I can expand. Ooh, there's someone right there. So I click on that. Notice that if I don't have this clicked on, see it's grayed out. Click on here, still grayed out. Nope, there's only one guy here, so it'll let you pick one. I picked the processor download. We have a connection with that processor because if we didn't, we wouldn't have gotten this far. Our Who Active would not have showed up this beginner L31 processor. Right now, it's talking to the processor, looking at what's in the processor, looking at its firmware level to see if it's the same, looking at the communication setup to see if it's the same. This is a every time you do it, every time you see it message. The message can be a little bit different. The controller is in a remote run mode. That can be different. So I'm going to lean over here a second and put it in a different mode. I'm going to click it to the program mode. Oh, looky there. Now it doesn't say that it's in the run mode. But I'm not in the remote mode either. So I'm going to go back. And now I'm in the remote mode, and I was last in program mode, so it should come up and say that it's in the remote program mode. It's still thinking. So I'm going to cancel this and do that again. Download. That's the problem with RS232. Even at 38,400, it is slow. You spend a lot of time waiting. Now this is okay if you're learning, okay? Connect a controller. So evidently it's only going to show me if I'm in the run mode. I just flipped it into the run mode. See? Key switch is in the run position. Now it says remote run mode. There is a little variation in this message. The only difference is if it's not in the run mode, then you can go ahead and download. But if it's in the run mode, it's warning you that the mode will be changed to remote program before it downloads. So right now it is running. If you were doing this out on the shop floor on a process that's making parts and you hit download, it's going to switch that processor to the program mode. Everything's going to stop while you download the program. That's not something that you want to do, is cause the processor and then process that's running and making parts to stop and accept a download, because that will mess up your parts. Done downloading. Change controller back to the run mode. Remote run mode, yes. There was a message here that we did not get that I'm going to go back and recreate, and I'm going to do that. Notice we're online now in the run mode. We are, see the little gears there changing? They're rotating up here by path. When you see that, and now watch this switch here. I flipped it to the program mode, flipped it back to remote. You see over here it says remote program, so watch these two together. Go to the run mode, back to the middle, remote run. Now we're in the remote run, but there is no program, so there's nothing to run. It's just executing an empty routine. However, what I wanted to show you was I'm going to go to controller properties, channel 0 serial port. I'm going to pick the default baud rate that the processor would come with from the factory, which would be 19.2. Think about what I'm doing. My laptop and my RSLogix driver are set up and configured at 38.4. Right now they're communicating 38.4 as we speak. See the little gears turning, and this is green. Right now they're communicating at 38.4. When I hit apply, that 19.2 is now going to become the configuration for that port. Result in loss of communications and inability to reconnect to the controller. Do you wish to apply the serial configuration changes? I'm going to say yes because I'm demonstrating something here. Again, we're suffering the timeout because the instant we hit apply and accepted it, that changed from 38.4 to 19.2. Now, RSLogix5000 through RSLogix is trying to communicate with that processor, and it cannot. So we just have to wait for it to time out. Not going to do any good to hit OK, cancel. We just have to wait for the timeout. Okay, can't communicate with RSLogix. Taken offline. Okay, see you have an error down here. This is the error window. I'm going to close that. It pops up automatically. Well, I have to say OK first. If online operations are in progress, they will not be completed. So we click OK to get rid of that. Get rid of the error window. This is at 19.2. Okay, so I'm going to say OK. And now I'm going to download this. The processor's at 19.2, but the program is still at 38.4. Whoop, no it's not. Made a liar out of me. So let's change this to 38.4 because that's what we want. Okay? We want 38.4. Hit apply and OK. But remember, this is the offline project, not the online. We set the online program configuration, COM configuration to 19.2, and we immediately lost communications. So now we're going to go back to RSLogix, configure drivers. See, it's set at 38.4, but remember, it's not going to find it at 38.4, it's going to find it at 19.2. See that? Configuration successful, 19.2. Say OK. Close. Now we can go online with that processor at 19.2. However, what I want to show you was this. Right now the processor is at 19.2. That's the way they come from the factory. We don't want 19.2. We want 38.4. So pretend like this is the first time you've done this. Open up your controller properties, which you can also do here. Go to channel 0, make that 38.4, and it is. Now, communications who active, and download. Now remember, RSLogix is set at 19.2. The project is set at 38.4. You're downloading the project, not RSLogix. You're going through RSLogix at 19.2. So right now, you are making contact with the processor. I know this, see it's green up here. It's starting to show you, it says you're in the remote run mode. Okay, so remember, we're communicating at 19.2 right now. But our project says 38.4. So watch what happens. Hit download. At some point, they're going to realize something's amiss here, because you're downloading a configuration, and when it takes effect, then you're going to lose communications again. Because remember, you're downloading a configuration of the processor that's 38.4. See? Now, do you wish to apply the serial configuration changes? I could say no and then go change it online. Or I could say yes. If I say yes, then I will lose communications with that processor. Then I have to go re-auto-configure RSLogix and then go online with the processor. Here's the quickest way to do this. Do you wish to apply the serial configuration changes? I'm going to say no. Okay. Change it back to remote run. Go up here to controller properties, channel 0. We're just checking this. Okay. I'm going to set this at 38.4. And I'm going to do the same thing. Either way, you're going to lose communications. So it's really 50-50 whether you change it here first or change it in your offline project. You're going to lose communications. Because remember, I am changing this inside the processor. See, I'm online right now. I changed it inside the processor. Now, I can go to RSLogix while it's doing that. If you're quick enough, go to Configure, Auto Configure, see 38.4. If I had done that quick enough, this would not have timed out. See, can't communicate. See, if I had done that quick enough, so once it starts, you've lost comm and it's timing out, trying to reestablish, you can go to RSLogix and re-auto configure, and you can do it fast enough where it brings it RSLogix configuration up to 38.4 while RS5000 is still trying to set up comm with that controller. Well, I hope I didn't confuse you too much. So, okay, we'll leave it at that. Next thing we're going to do is the I/O.